Alrighty, so very last thing we have to do before we start revising is look at a speed time graph. So on Saturday we should have looked at some distance time graphs, now we've got to look at speed ones. So speed time graph is exactly what it sounds like. It is the graph of where you are showing speed, and we always put speed on the y-axis, okay, so on the vertical axis. And usually we record speed in meters per second, but it could also be, kilometers per hour, any other kind of units you have. And then we have time on our x-axis. So we're looking at speed versus time. For a distance time graph, the gradient of that graph, okay, gave you the speed that the object was going at, or that the object went at, and we found that by doing the distance, for one section of the graph divided by the time. Okay, for a speed v time graph, the gradient of that graph, gives you your acceleration, and your acceleration tells you about how your speed is changing. And we find the acceleration much the same as we do distance versus over time. To get the acceleration, we do speed over time for a certain part of the graph. When an object is speeding up, so when the speed's increasing, we say that it's accelerating. Okay, when the speed is going down, or the graph's going negative, we call that retardation, and you can also call it well, in Australia we call it de-acceleration, but I think your textbook generally tends to use retardation instead, so think about that. Okay. Now the last thing is, if you want to know the distance from a speed time graph, we can also actually work that out. We do that by finding the area under the graph. And to do that, we have to break up the graph into different pieces, and then we calculate the area of each piece. And I think the easiest way to show you how to do that is an example. So here we've got an example of a speed time graph. Overall, our time is 50 seconds, and we can see our speed changes. So firstly, we're increasing our speeds, then our speed becomes flat. And a flat speed, if your speed is increasing, that means you're accelerating. So that means your gradient is positive. Okay, your car is accelerating. When you've got a flat line, much the same as with the distance time graph, the flat line told you your speed wasn't changing. The flat line for a speed time graph tells you that your acceleration is not changing. That's what we call constant acceleration. Okay, our line then becomes, then has a bit more of a gradient. So now we're increasing in our acceleration again. So acceleration is positive and our speed is increasing. And then we stop and our speed starts to decrease, and our acceleration would be de-accelerating or retarding in this stage here. So it would be getting lower. Okay, so for the speed time graph, we want to find the acceleration over the first 10 seconds. So if we're looking at acceleration over the first 10 seconds, okay, we find 10, we're looking at this part of the line. So what is the gradient of that part of the line? Well, our maximum speed is 15. Our smallest speed is 0. And our biggest time here is 10. So when we've got that coordinate, that there is 10, 15. So our biggest time is 10. And our smallest time down here is at 0, 0. Okay, so we can now work that out. So 15 divided by 10, okay, which is 1.5. And our units is meters per second squared for acceleration. Okay, so acceleration, whatever the same as whatever your speed is, but you've got a squared on the end of that there. Okay, next part, we want to work out the retardation over the last 20 seconds. So again, let's just change that highlighter, make it blue. Okay, so we're looking at this part here. Now this is going to be decreasing, it's going to be negative. because our line's going down. So first thing is we need to look at our coordinates again. So here we've got 30 and 25, and then that goes down to 50, 0. So our d acceleration, okay, is equal to, now we do y coordinates first, so 0 minus 25 over 50 minus 30 for our x. So that's negative 25 over 50 minus 30 gives us 20. Okay, so negative 25 over 20 is negative 1.25 meters per second squared. Okay, so that would be our d acceleration, negative 1.25 meters per second squared. All right, the total distance traveled in meters. Now this is where it starts to get a little bit tricky. Okay, so to find the total distance in meters, we need to calculate the area of everything under the graph. So we want to find the area of all of the shapes under the graph. So what I'm going to do, I'm just going to clear out some of this stuff that I've already drawn. All right, delete that. Now, I'm going to break this up into the best kind of shapes that I possibly can think of to do. Now, most of the time when we're calculating areas of shapes, we want it to be things like triangles, rectangles, things that are nice and easy to calculate. So I can see here, if I cut this down the middle here, I have this really nicely well-defined triangle here between 0 and 10. Then I have a rectangle between 10 and 20. There we go. That's another nice one. I then have another, I can kind of make this into a rectangle here. Ooh, maybe not that far, because then you can see there's not a good line there, so we'll get rid of some of that. So I can then, I'll make this into a rectangle here, this rectangle there. Okay, then I've got another triangle on the top here. Okay, and then I've got this big triangle down the bottom here. So all together, I'm going to calculate the area of 1, 2, and I'll number them off. 1, 2, 3, 4, 5 shapes altogether. Okay, so my area of my first shape, so number 1. Now it's a triangle, so the formula for the area of my triangle is base times height over 2. So my base is 10, the height is 15, I'm dividing that by 2, so that's 10 times 15 is 150, divided by 2 is 75. Okay, so that's my area, or my distance. Now I'm going to put that in meters. That's the distance that I've travelled in that first 10 seconds. My second shape is just a rectangle. So my rectangle is length by the width. So that's 10 by 15, okay, which is 150 meters. Okay, so within that next 10 seconds, I've then travelled 150 meters, and I might actually put this on here. So I'm going to write 75 meters there, 150 meters here, and then I can see where I'm going to add them together later on. Now this next bit's a bit tricky, because if we're calculating the area under this, we actually have to break it into 2 shapes. So we've got another rectangle bit, and that second rectangle bit, again, it's 10 seconds. 10 seconds times by 15 again, if I carry that across, 15 again. Okay, so that's 150 meters again. But then the fourth bit is this little triangle on the top. Now that's base times height over 2, okay, which is 10 for the base times by 10 for the height divided by 2. So that's 100 divided by 2, which is 50. So overall then, for 3 and 4, my total distance is 150 plus 50, which is 200 meters for that part there. Okay, and that's because the reason why this distance is so much bigger than these ones is because I'm going at a much faster speed here. Okay, my speed is between 15 and 25, so I'm covering, even though the space of time isn't very big, I'm covering a really long distance. All right, then the last bit, my fifth piece. So for my fifth piece, I'm going from so again, it's another big triangle. So I've got base times height over 2. So I'm going from 25 is the height of the triangle, times by 20 for the base over 2. Okay, now I'm going to do this on my calculator. 20 times by 25 divided by 2 equals 250. So now I've gone 250 meters on that space there. Now, when I add them together, I've got 250 plus 200, that's 450. So 200 plus 250 equals 450, plus another 150, that gives me, well, plus 50 is 500, plus another 100 is 600, plus another 75. So that's 675 meters altogether. So I'm going to write here, total distance equals 675 meters. All right, now last thing is the average speed. So for the average speed, I'm just going to rub some of this bit out here. Okay, so for the average, if we want to work out the average speed, we take the total distance that we've traveled. Okay, so average speed equals total distance divided by time, okay, which is 675 over 50, because that's my total time, 50 seconds. So I'm then going to work that out. 675 divided by 50 gives me 13.5. And that's meters per second is your unit, same as whatever your speed unit is there. Okay, so average speed, 13.75 meters per second. Alrighty, hopefully that made sense. I've just got another quick one I'm going to show you here. This one won't be as long. So what you'll notice about this one is it's a curve, so it's not going to be nearly as easy to estimate the distance for this one, but we can do it. So first thing we want to know is A, what's the minimum speed? Well, what's your lowest value there? It's 0, so my min speed equals 0 meters per second. Okay, very boring. B, what is happening to the acceleration of the object over the 4 seconds in words? Well, what is happening to it? It starts off and we can see the speed really drastically increases. So we have a massive increase. So acceleration is increasing increasing, we'll say substantially, for the first, well, we would say that about 30 seconds. Okay, so we can see it's increasing a lot there. And then after that, the acceleration starts to decrease. Your speed is still increasing, after which it begins to decrease to a more constant acceleration. Okay, so it's beginning to decrease to become more constant. Okay, it's still increasing, but it's not increasing as steeply as it was at first, and that's because you've got more of a curve there, and then it becomes slightly more of a straight line. Okay, you could write more than that, more detailed if you wanted to, but I'm happy with that for the moment. Okay, estimate the total distance. Now, you'll notice that this says estimate and not calculate. The question above says calculate, and that's because you had those straight lines, so we could calculate it. Now, for estimating, it's a little bit different. We're still using rectangles to work this out, but we can't do it in the same way as we did before. So, well, that's not a good colour. Let's use yellow. Okay, so what I want you to do is we're going to break this up into 4 pieces because there's 4 seconds altogether. And then what you do is we're going to make these into rectangles. So we've got, so I'm going to say that's about 4.5 there, okay, and then this is about 6.5 there, and then this one here, that's about 8, and then this one here, that's about, so it's about 9, okay. So my rectangle number 1, okay, is 1 second, because that's the width, 1, times by 4.5, so that's 4.5. Then my second one is again 1 second, because that's the width there. 1 times by 6.5, which is 6.5. My third one is going to be 8 times 1, okay, because my top speed is 8 and my distance is 1, so that's 8. And then my fourth one is 9 times by 1, which is 9. So my total distance that I've gone is 4.5 plus 6.5 is 11. Plus 9 is 20, plus 8 is 28. So 28 meters altogether is my total distance. Now lastly, average speed is 28 over 4, which is 7, because that's the total